Good evening, friends. Welcome to Eastern Academy, and we are discussing about controller programming. Today is session 5, and today's topic is going to be interrupt controller. Sorry, interrupt controller, not internet. Interrupt controller. This is a very important topic, and the most used in embedded systems. Okay, so let us try to understand the basic concept. This slightly differs from each microcontroller and microprocessor. So let's not get into the processor detail that you will understand when you're getting into the thing while implementing. But let us try to understand what is the top level. Okay, the top level has to be understood very clearly about interrupt controllers. Okay, let's go on to the board. So what is interrupt controller? That is quite simple. We have discussed so many times a microprocessor. The microprocessor has address lines and data lines and write, read. This is a control line. So with the help of address and data lines and the control lines, microprocessor could do two operations: write to memory and read from memory. Okay. Microprocessor does two operations. Okay. And microprocessor gets a power supply. We know that. It gets a clock. And it gets a signal called reset. So when you give a reset, it starts from 0, starting address. And when you give a 5 volt, it does it. When you have a thing, this is the way it works. So this is what all about the microprocessor. But it has one more signal called int. That's called interrupt. What it does simple. It does simple. When you write a program in microprocessor, you write in either C or assembly, whatever it is. You have some instructions. And from anywhere, you can go to any line. So I have some program. I have some programs. This is line 1, line 2, line 3, line 4, line 5, 6. You can see if we say go to line 6, the program will go to 6. Otherwise, please understand, this is a very important point. This microprocessor always execute the instruction from memory one by one, sequential. Understand? This microprocessor executes instruction only sequentially. It does not jump. It goes only line by line. Provided if you have an instruction called jump to some address 0006, then it goes to this directly, bypassing this 2. Then it goes from the here to here. It does not come here. Provided you do it. If you don't do that, if you say add any other instruction, it will come down. Like that, like jump, there's an instruction called call. The call means it will go and come back here. See, when you use jump instruction to microprocessor, it will go to 6, jump 6. It will go to 6 and continue. It will never come back. It's gone. It does not know from where it has come to 6. But instead of jump, if you use call, 6. It goes there. If it execute, if you get the instruction called return, it knows it has to go back to 4. It remembers from where is the next instruction when you call. So there's a big difference between call and jump. That is what here. Okay. Now, this interrupt generate the jump. Understand? There's a big difference. In your code, if you have a jump or call, this is generated by software, your software. But whereas when the interrupt comes, the microprocessor jumps, calls. This is called hardware jump or hardware call. Understand that that's what the big difference. The trick is that when I am doing a software, I know that where I have a call. But when I am doing the interrupt, you don't know when it will jump and when it will come back. This is called asynchronous. This is called synchronous. So you know that when it will happen. But here you don't know when it will happen. So why do we use this? That is what the trick. Every microprocessor manufacturer tells you that when you get this signal here 5 volt, 0 volt to 5 volt, when it goes to 0, 5 volt, this microprocessor goes to the specific location, maybe 4,000 or 6,000, whatever it is. They call that as a interrupt address, or they call the special name called interrupt vector. Both are same. Address and vector are same. So don't get confused. They call it a vector. So when this is unique, this is different from each microprocessor. So each microprocessor will have a different addresses. Now, when you go to this instruction, when you say return, it will go back from where it has come. But without you are executing any call instruction, when they get a 5 volt here, this is indirectly here, you can call hardware call instruction. So you have to be you have to understood very clearly. This will come and come back when you do return. That's the thing. This is called, this function is called interrupt service routine. Am I right? This is called interrupt service routine. So is it clear? That is, I am calling a function. That is, you call generally. You say that you call a function called add main. In main, you have a code. You write and you call add function. This time you are calling a function. But whereas this function ISR, you don't call the function, but this will be called by the interrupt. So this function should be placed at the right place. Understand? This function has to be put at the right place. Okay, that is at the place. You should understand how each compiler does it. They will say have a keyword call. They will call a function call int ISR interrupt. If you say interrupt, they understand, the compiler understand this is the interrupt function. Understand? So somehow you have to inform the compiler this function is an interrupt function, then you put it there. So this is a very simple logic. That is, I get the interrupt. When I get the interrupt, that guy, so First of all, you have to understand what is interrupt. That is, I have a microprocessor. Simple. The microprocessor executes the instruction from the memory sequentially, one by one. And it has the 4 lines that, as we discussed so many times: write, read, data, and address. This is very simple. Now you have a signal called interrupt. It's a new signal. What this signal does is, when this becomes 5 volt, 0 to 5 volt, that time this microprocessor, wherever it's executing, it stops there, stops, and stores the address. Address could be, let's say, 1, 2, 3, 4. It stores the 4 somewhere in the memory. We call it a stack. Then, after storing the 4 there, this microprocessor jumps to the ISR. Where it will jump, that depends on the microprocessor manufacturer. They will tell you that where to call, where to go. Okay, this address is individual microprocessor based. Then you write a software here that is called ISR. At the end, you should return. Then it will come back to this instruction. It will continue. So whenever you give a signal here, the microprocessor will temporarily, like let's say you are doing some work. You do some work. You read a book. You read a book. Okay, or you write program. You do some activity. Suddenly, if there is a phone call comes, what you do? So you stop here, attend the phone call, you answer the phone call, then come back to the place where you left. I mean, you remember where you left. Either you do marking or writing, whatever you do, you remember where you have left. Then after attending the phone call, you come back to this work. Am I right? This is called, the phone call is called interrupt. The phone call interrupts you, please. Now, this is smooth where it is used. It is used like this. Let us assume that I have very simple case. Let us have a very simple case. I have a timer. And I ask the timer through my address, write, read, and data. Using that, I ask the timer to count a number up to, let us say, 5,000. And that guy is having another count which is 0. The moment I tell the timer to count, he will start from 0 counting. The moment it reaches 5,000, it compares both. Once the comparison is successful, then it will generate that timer will generate an signal called interrupt. Am I right? The timer generates a signal called interrupt. So once the interrupt comes here, this microprocessor may be doing some work. Let us assume this guy is having a clock. The clock interval is 1 millisecond. Since you're given 5,000, it will count 5,000 times. So 5,000 milliseconds. It's equal to 5 seconds. It is equal to 5 seconds. Am I right? That's a trick. You have 5 seconds. Now, within 5 seconds, you do lot of instruction. And whenever this interrupt comes, you are here. Then you get stopped here. Stop. Then go back to the ISR. This is a timer ISR. Okay. This where it is putting is based on the compiler, based on the microprocessor. They know where the interrupt has to be placed. Okay, it will be placed that place. You can also place it. That I'll tell you later. Okay, you can also place it having a function pointer. You can put the function pointer and you can put the function there. Nothing wrong. Okay. If it's a RAM, you can change. If it's ROM, you cannot change. That's a problem. Okay. So ISR. Now at the end of the ISR, you have a return. Then it goes back to the next line. Here, you know that whenever the ISR comes, the timer has given the interrupt and every 5 seconds. Let us assume that I have a LED here. I connected a LED here outside. Using this ISR routine, I can toggle the LED. So it will blink every 5 seconds on, 5 seconds off. I can toggle it. That you should know how to toggle it. That is using a XR function. So if you use a XR function, it will toggle. So this is the timer is a controller. When a controller gives an interrupt, now let us assume that we have another controller. Forget about timers. I have a controller called disk controller. And I have a disk. Okay, I have a hard disk. Hard disk controller. Let us assume that hard disk controller. Now, this is called hard disk drive. This is called hard disk controller. Please understand the difference between HDC and HDD. HDD is hard disk drive. This is a device like LED. LED is a device. Please never confuse between the device and the controller. Controller is sitting in between your microprocessor and the device. Okay. So this is the way your interrupt works. This is we practice very clearly. If you have seen my timer code, I have shown you that how the interrupt is working. Okay. Now it's a trick. The trick here is, see, I was explaining about hard disk controller. Suppose you want to write in a disk, in a sector, some data. Then the microprocessor tells the hard disk drive, you write the data at somewhere at the disk. What the hard disk controller will do, it will write the data there. Then it will give an interrupt saying that I have completed. Then only microprocessor will give the next data. Normally, let's say each sector is 512 bytes. You want to write a 10K file. Then after every interrupt, I'll start giving another data. We'll be doing that. So these are all the fundamental operations of processors. Okay, so as of now, whatever I discuss, if you have any doubts, let me know. Because we are going to proceed from that. We are going to proceed from here. If you have a doubt here, we cannot get into the next one. Please. Let me have a so no doubts. So now the problem came. The problem is I have a timer controller. I have a hard disk controller. I am using both. Now this guy also giving an interrupt. And this guy also giving an interrupt. Understand? Both are giving the interrupt. Now, this microprocessor has 2 1. Let us call this as a int 0. And let's call this a int 1. 2 interrupts. So what is the advantage now? The beauty here is this microprocessor is designed in such a way that in a memory, when this becomes 1, interrupt 1, I will go to the specific location, int 0. When I have a int 1, I go to other location. You understand? So you should have a 2 function. This is called ISR 0 for timers. This is called ISR 1. This is called hard disk controller. So this microprocessor is designed. Let us assume that you are executing the function here. You are executing your program. Now, if the int 0 becomes 1, if the int 0 become 1 at this place, your function comes here, it stops here and comes here. By chance, instead of this becomes 1. Which one? You are the hard disk controller interrupt. Then this guy will jump here. Okay. So this is that. These are all the hidden information of microprocessor. Understand? These are all where it will jump. Depend. We'll see that. We'll see one of the controller and see the addresses where it will go. Please. Let's see that now itself. One minute. Yes, once I shown you that, then you'll be able to understand that.
Sir, does hardware disk controller have a separate pins for interrupts?
Correct. Yeah, it has multiple pins. Correct. I'll show you that also. This microprocessor have with different pin for different interrupts. Let me show you our known data sheet. Everything is fine, but anything is known one is very good. Let us see that this is a very easy controller. See, small one, 8-bit controller. So we'll see that. See, this is interrupts here. When I go to the interrupt here, you see here. Let me make it big. Is it visible to you? See here. This guy. See here. For every interrupt, there are so many interrupts. Am I right? For every interrupt, there is an address given here. Timer and the external interrupt, the pins, outside pins, and SPI, I2C. We'll discuss about that next. What are the things? For everything, there is a specific address given. It will go there automatically. So your code should be there. Understand now? So this is a very important, this is called, see that here they call program address, here they call interrupt vector. This is called the thing. So vector number 1 means this address, 2 is this address. For example, this guy is handling 26 interrupts. More or that, let's see here. Yeah, only 26. Yeah. This is what they are having a function here. If it is 0 means they jump to reset, jump to interrupt 0, jump to interrupt 1, like that. There you will have a function. See here, timer 1 comp A, timer 1 comp B, like this. These names are fixed here on AVR. This is a AVR controller, so the name is fixed. So you understand that this address is the one. On this address, I have a function called jump to this location. So it will jump to the location. There you will have a function. Codes. Okay, so study more. That then only we'll be able to know that. No, not let's not worry. Now I'll also show you the this one diagram, pin diagram. In the pin diagram, you see that here they will say that interrupt 0 and interrupt 1. Somewhere they will be there. Every pin is interrupt. That maybe you can use every pin as an interrupt. But apart from that, there is a special 2 pins are there for int 0 and int 1. That if you have to thoroughly understand this, it will take time. Okay, so see, this is all int 0. They don't have. Let me check.
Pin 1, PD3.
Yeah, pin 1. Pin 1 is not int 1. That's correct. Thanks. Pin 1 is int 1. Okay, I'm not. I don't remember the microprocessor things because I use lot of microprocessors. Everything I cannot remember it. That's the thing. Same way int 0 will be there in some other pin. Okay, so
the PD2 sir, interrupt 1. No.
Where is it? Where is it? Int 0? Do you see that?
32 sir. PD2 top.
Oh, fine. 32. Call correct int 0. Because I saw that one only. I will tell you what is this also. There's a trick here. If you go down here, interrupt, you'll be surprised here. You see here, this is called pin change interrupt. 0, 1, 2, like that. For example, what is that? That is pin change interrupt is nothing but every pin. I'll show you that here. See here. Every pin, they changes the bit. Okay, they'll be able to give you an interrupt. See, so many things. Every PC int 8. So if you start reading this, how many pages? This is, if you see here, this is which page it is, 49. And this is ending at which page? Very simple, about 10 pages. 10, not even 10 pages. It's about say 7, 8 pages. So assume 10 pages. 10 pages you can read it. If you don't understand anything, ask me. I'll be able to give you. Now I'll explain to you something extra. That is what the important. Now I'll explain to you that there is something called interrupt. And when there is an interrupt comes, there is something called interrupt. When there is an interrupt comes, the hardware will jump to the location. This has to be understood. This is common in all the microprocessors from 70s to 2022. No change. Understand now? Is it clear? Now, the problem came was there are so many interrupts start coming. So what later they have done was this is the way they handled it. The handling was very nice. I have a microprocessor. Microprocessor has only one interrupt pin. How many interrupt pin? Only one interrupt pin. But I have another device which is called interrupt controller. Interrupt controller that will have multiple pins, any number of pins as you wish. Now, let us in this case assume that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 interrupts. Whenever there is an interrupt, let's say fifth interrupt is become 5 volt now. All the others are 0 volt. All the other pins are 0 volt. And if this guy become 5 volt, and this guy will generate the interrupt. Am I right? This interrupt will be generated by this guy, this become 1. If one of the pins comes the interrupt, so the microprocessor will get only one interrupt. Think of a minute. Think of a minute. I get so many people, visitors. I get so many visitors. Then everybody start coming, knocking the door. Am I right? All the people knocking the door. I get confused. So I have to appoint a receptionist. I appoint a PA or receptionist. That receptionist will interact with all the people. Then tell you that so and so had come. Then you will ask the person to come and do the activity for you. That is exactly that. That is what this guy's job, interrupt controller. What will happen? This guy will have a register inside. This guy will have a register inside. Now, this microprocessor, once you get the interrupt, it will go and read that and find out who had come. Okay, based on that, that guy will start acting. So the number will be coming here. Which one has come? Which one is given an interrupt? Let's say I have about a 8-bit and another 8-bit. I will read this, which are all 1. Based on that, I will do the activity. There'll be only one function here, not multiple function. Now, in my memory, there'll be only one ISR. Understand? Now I have only one interrupt, only one ISR. But this interrupt service routine goes and reads that this guy, what is the value of register? Then based on that, that guy will do the activity. Is it clear? Now, what are the other advantages of the interrupt controller? This microprocessor can tell him who? The microprocessor can tell the controller, hey, don't disturb me if any interrupt comes, assuming that any interrupt comes. There'll be a switch here. There'll be a switch here. Now, if I tell the controller, don't disturb me. Don't disturb. When the microprocessor tells the controller, that means that it will write to the register. That's all. Speaking means write to register. Don't disturb. Then this switch will become off. That means that if all the interrupt comes, the microprocessor will not be disturbed. Am I right? The same way. If say fine, this is called, we normally call enable or disable. Enable or disable interrupts. That is what the concept now. Now, the trick here is this. After enable or disable the interrupt, I can also individually tell the controller, hey, don't allow the interrupt except 6 and 7. Don't allow everything. So then what happen? 6 and 7 will be 1. All the others will be 0. So I can disable. I have a register to disable individual interrupts. Understand? I can disable. This is generally called, we use the call mask. We use the word called mask. Mask means block. If you put the 0 on everything, then it's mask. 1 means unmasked. So if you mask the interrupt means disable the interrupt. So I can mask any individual interrupts. That is possible. So what you can do, I can do global enable or disable. That is possible. Second one is individual enable or disable. That is possible. What is the third one? Third one is I can set the priority. If there are 2 interrupt comes here, 5 and 6, I can make the priority bit set here such a way that the microprocessor will handle this guy is a priority than the other guy. So I can have a multiple priority. Understand? So I have a multiple priority. I'll give an interrupt, let him handle one, then he'll give the other one. I'll make them queue. That's advantage. So priority. Next one. I can program him when it is level high or level low. When it is 1, I should get the interrupt, or when it becomes 0, I have to get the interrupt. That I can able to configure this guy. So no, I'm trying to tell you that why I should need the interrupt controllers. Advantage is I get only one interrupt to the microprocessor. Correct. Priority is set by the programmer. The programmer can set that which interrupt I have to get the highest priority. That guy, nobody will know except you. You are the only guy who knows which one to be given the highest priority. That's the advantage of interrupt controller. That gives you the facility. You can say that, hey, I want interrupt 9 to be highest priority and interrupt 11 to be the lowest priority. You can say that. Now, when you start, let me have one of the controller I'll take and do these things. When you start getting into the interrupt, that time start read the watch. Right now, if you listen, not much use. When you're going to implement it, watch those videos. Let me try to record more videos on that. When I get a time, I'm trying to record more number of videos, but I'm not currently. I'm currently busy with some projects. I'll be free shortly. Now, take the next one. Like there is something called edge. There's something called edge. That is low to high or high to low. I can tell him that when the pin number 10 become low to high, gives me the interrupt. Then if it is all keep on high, I will not get interrupt. Once it become low and low to high, it will give a thing. So I get an interrupt when it is on edge. That is the next thing of this interrupt controller. So today, every ARM processor you go and take. Now you know that we got the advanced processor like ARM and all that. Everybody is having an interrupt controller. Of course, when you do the ARM, I'll explain to you there are 2 types of interrupt. One is called IRQ. They have FAQ. One is fast interrupt and slow interrupt. That we'll discuss later. This guy had 2 interrupts, IRQ and FAQ. Let us discuss about when you discuss about ARM. Right now, don't worry about the that level. So that means that it's like this. I have a ISR, interrupt service routine. This is a main service routine. whenever there is an interrupt comes, it comes here to ISR. That guy read the interrupt status. Read interrupt status. Okay. Then read interrupt status. Based on that, he will do case 0 means go here. Case 1 means it go here. So based on the interrupt, it will jump, it will go to the right position, right function. So there is only one ISR. But the programmers have given a good advantage. The thing is that there is a facility available nowadays in our software. All the provision that's basically on OS, RTOS or Linux or any other OS. You can register your own function. How to do that? Now it's like this. Let us say that you write a function. You write a function now. Some call ISR hard disk. You write a function. After compilation, this way you will be put on memory, you get some address. And you call interrupt register, a function. That name may vary. You give a parameter called HDC int. This will be there in the H file. Let's say this file called interrupt.h. The file you will have that hash define HDC int 0 timer int 1, like that. It's all available here. Now, when you say that interrupt register function, you give the interrupt number and you give the address and ISR HDC. You understand? You are giving the interrupt number and you are giving the interrupt address, the function address. That's it. Now, this will go to the interrupt register and that guy will hold it on a table in the memory. Now, the thing is here, when I say case 0, he will have a function called star ISR. Star ISR. Am I right? Star ISR. There's a function. Now you will say here, I defined here a function called star ISR something. Now we'll say here ISR equal to this one. ISR HDC. Then I'll say star. This is called a pointer to function. It's not function pointer, it's the thing. Now you see here, there are two things. Please don't get confused between two. I have a function called function 1. This means that the function is returning a pointer. If you put here star function, this is pointed to the function. Understand? This is the function is returning the pointer. In this case, the function itself is a function pointer. This one. This is the way you are registering your. These are all typically used something called callback also. You will hear all those things when you start moving into slowly to the next level. That time, ask me any doubt on the WhatsApp. I'll explain to you. Now I know that it's all on the air and confusing you. I know that, but I just putting the words. I putting all the terminologies like. That means that what I'm trying to explain to you is that Your ISR function is for all the interrupt. Now you can register your own function for the vector, for the particular vector, and whenever there is a interrupt happens, it will call your function. You can register your own functions. Okay, you have to be very careful in this case. Normally, these are the places the virus used to spread, but in embedded, your own program, virus cannot come in. Okay. So you can, this is what, if, let's say I write a small function, assume that add something. I have a function. You put star function. Now I write a function main. Next week when we have a class, I'll explain to you this. I'll do the live. I will put here function is equal to and add. Now you write here star function. If you call now, you are calling the star function, but this function will be called because you initialize this function with this address. This is typically used in the interrupts. Because your function has to be told to the OS. Okay, they are only managing all the interrupt on the main ISR. How they will know that which function and this function, you have to link them. For that only you fill the table. That activity is called register. You are registering your function to the OS. Only that time they will use this type of pointer to functions. Is it clear? So any doubts on the interrupt? So interrupts are very clear. We have every microprocessor is having a pin call interrupt. And we have an interrupt controller. Which takes multiple interrupts. Interrupt controller takes multiple interrupts. And these interrupts will be sent to the microprocessor one by one with the help of the interrupt pins. That is, you have so many registers to control so many functions. As we discussed, enable or disable or edge, priority. That's all. Masking is called enable, disable. So that's the way, and the status. So many things are there with the help of the interrupt controller. So it's a good thing to handle. And also in interviews, if you say that I have handled the ISR and I know about interrupts, and people will give you good weightage. And especially if you handle it in the ARM. If you handle it in the ARM, then that will be very, very, very valuable. Okay. Okay, understand. Any doubts you can ask me now. This is what the top level. Please understand this picture very clearly. That if you understand, you are done. So interrupt is a very easy topic, but only problem is that ISR will come anytime. So your software will be running something and the interrupt can come anytime. You should be able to how to handle it. Let's say you are doing some activity, somebody knocked the door. That time, how do you act? That is the way here. And you should be able to store it and come back. If you don't want, you can tell the receptionist, hey, whoever comes, don't allow them. Allow it to me. That's why. That's called disabling everything. I'm doing some busy work. You'll be doing some important work. That time you tell the interrupt controller, don't disable me, don't allow me to interrupt. Is it clear? So if you have any doubts, you can ask me now. Otherwise, we'll have a break. We will get into the next topic after this break. That's another most important topic. So basically, these are all nice topics, and you better know that and use it as a functions. That will be very good. If you start learning this also, I have to parallelly, and parallelly you start using the functions also. Yeah, it is not in this one. What do you call your interrupt timer? The timer itself is giving the interrupt. We have having an interrupt. If you want, I've not yet written a program for interrupt controller, which I'll do that. Maybe I'll do that. I'll try to write about 5-6 interrupt handling, how to do that. Let me do it and release it sometime next week. Now I'm doing one by one all the activities on the WalkMe. Let me do that. I have not yet written any program for the interrupt, please. Okay, then let me. I think I've